Hello. In the previous exercise, we started to look at the graph of parabolas. In this exercise, we're going to start with the basic parabola, which is y equals x squared, shown here on the screen. And we're going to see how this changes. For example, it might move left and right or up and down. Now, I've color-coded these graphs as we go. If you've printed them out in black and white, you might like to highlight them or color-code them as we go through it. So the first thing we're looking at is something called a dilation. So when something's dilated, it's either getting narrower or wider. So we've got our basic graph here, y equals x squared. Now let's see what happens if you make it y equals 3x squared. That's the blue graph. And you can see that the graph has become narrower or skinnier. And now the red graph, y equals 1/3 x squared, you can see that the graph is wider than our original. So if there's a number in front of the x squared, then the graph has been dilated. If the number is bigger than 1, then it's going to become narrower. If the number is between 0 and 1, then it's going to become wider. So here's a summary of what I just said. For y equals ax squared, the a term affects the dilation of the graph. If a is greater than 1, then the graph is narrower. And if a is between 0 and 1, then the graph is wider than our original graph. Alright, next we're looking at translation. Translation means to move, and here we're moving up and down. So again, we've got our basic graph that we're always comparing to, y equals x squared. And the first one we're going to look at is y equals x squared plus 1, which is the blue graph. So have a look at the equation. The only difference is we've got a plus 1 on the end. And what has happened to our graph is it's kept the same shape, but it's just been moved up 1 unit. And to look at the other graph, the red one, it's y equals x squared minus 2. And it's the same graph, it's just been shifted down. And it's been shifted down by 2 units. So hopefully you can see that if there's a number on the end, that will translate the graph up or down. And if it's positive, it's going up, and if it's negative, it's going down. Just to emphasize that, let's record the turning points of each graph. The point where it stops going down and starts to go up. So for our original one, the turning point is at 0, 0. Now for the blue graph, the turning point is here, which is 0, 1. And for our red graph, the turning point is down here, which is 0, -2. Next, we're altering our equations in a different way. Instead of having a number added or subtracted on the end of the equation, we've got a number added or subtracted inside the brackets, inside the squared bit. And you can see from the picture that the effect is to move the graph sideways or horizontally. So our blue graph here has got x plus 2 all squared, and it's been moved 2 units to the left. And the next one is x minus 4 all squared. That's been moved 4 units to the right. So let's record the turning points. For our original graph, the turning point is 0, 0. For our blue graph, the turning point is -2, 0. And for the red graph, the turning point is 4, 0. Now the convention for writing out this term is to call it the h term. So y equals x minus h all squared. And the convention is to have a minus sign in here. So one of the graphs on the previous page was this one, x minus 4 all squared. So if you compare these two graphs, or two equations, sorry, you can see that h is equal to 4. Just by comparing this with this. H is equal to 4, positive 4, and so the graph has moved 4 units to the right. With the other graph that we had, the equation was y equals x plus 2 all squared. Now in this case, what is h? Have a look at comparing these two equations. If our basic equation is x minus h, and then the question says x plus 2, h must be negative 2. I know it doesn't really look like it because you've got a plus sign in there, but compared to our standard one, in order to get it like this we're saying h is negative 2. So in this case h is negative, and the graph moves to the left. So that last bit can be a bit confusing. Here's another way to think of it that might help. What you can do is you can take the term that's inside the brackets, which in this case is x plus 2, and you can set it equal to 0. Now if I try to solve this for x, to get x by itself, I have to move the plus 2 to the other side. It'll become negative 2. So our turning point happens at negative 2. And the graph has been moved 2 units to the left. Another thing that can happen to our graph is that it can be reflected. So we've got our basic y equals x squared. Now the next one is y equals negative 0.25 x squared. Now we already know from previously that the 0.25 will dilate the graph, and because it's between 0 and 1, that will make it wider. But the thing I really want to look at here is the minus sign. The effect of the minus sign is to reflect the graph so that it's downwards. The unofficial terms is we call this a happy parabola because it looks like a smiley face, and call this a sad parabola. It's not a really mathematical term, but maybe that helps you remember it. The more mathematical way of saying it is that if the x squared term is positive, like the black graph, then the graph is upright. And if the x squared term is negative, like the blue graph, then the graph is inverted. Example 1. State whether the graphs of each of the following equations are wider or narrower than the graph of y equals x squared, and state the coordinates of the turning point. So the first one, it's got 0.6 in front of the x squared, so hopefully you remember that that makes it wider. If that number, that a term is between 0 and 1, it's wider. And the turning point hasn't moved, because dilation doesn't move it, it just changes how wide it is. So the turning point is still 0, 0, like our basic graph. Now for part B, look at the a term, which is the number in front of the x squared. This is bigger than 1, so it will be narrower. And once again, it hasn't been translated, so the turning point is still 0, 0. Example 2. State the vertical translation of the graphs of the following equations and state the turning point. So the first one has been translated upwards because it's positive, and it's been translated up 18 units up. And so the turning point, instead of being 0, 0, it's been moved 18 units up. So it's still got an x value of 0, but the y value is 18. Part B, you can hopefully see that it has been translated downwards because of the minus sign, and downwards by 3.8 units. So the turning point is 0, negative 3.8. Example 3. Y equals x minus 7 all squared. This has been a horizontal translation because the number is inside the brackets, it's all squared. And the first one is 7 units to the right. And so that means that our turning point is in 7, 0. Part B, this one is going to the left, and it's going to the left by 5/7 of a unit. So it's gone to the left, so the turning point is -5/7, 0. Example 4. State the turning point of each of the following and state whether it is a maximum or a minimum. So the first one has been shifted upwards by 5 units. So the turning point is 0,5. And is it a maximum or minimum? The minus sign out the front means that it's one of those sad parabolas. It's going to look like this. And we call this a maximum because the turning point, which is here, the bit where the graph turns around, that's like at the top of a hill. So it's called a maximum. Part B, the turning point. Well, the graph has been moved 8 units to the right. So it's 8, 0. And there's no minus sign out the front, so it's a happy parabola. And we call this a minimum, because if you look at the turning point, where it turns around, that's at the lowest part of the graph. So the turning point is called a minimum. So just to recap that new concept, if the turning point is the highest part of the graph, we call it a maximum. If the turning point is the lowest part of the graph, we call that a minimum. Last example. Sketch the graph of y equals x minus 3 squared plus 2 on the following set of axes. A graph of y equals x squared is being included as a reference. So here's our basic graph. I want you to press pause and see if you can sketch this. So think, is there a dilation? Is there a horizontal translation? Is there a vertical translation? Then you can work out where the turning point is and draw it in. So press pause and have a go. Okay, hopefully you've got it now. First of all, there is no dilation because there's no number out the front here. So it's going to keep the same basic shape. There is a translation. We're going 3 units to the right and 2 units up. So the turning point will be at x equals 3 and y equals 2. And that's because the graph has gone 3 units to the right and 2 units up. So that'll be our new turning point. So once you've found your turning point, it's quite easy because there's no dilation, so it just keeps the same shape. So just try and draw it roughly the same as the original graph there. And there's your answer. Alright, that's the end. Good luck with the exercises. Bye for now.